Okay, so now we're going to talk about our next topic, which is linear algebra. We're actually going to do a lot of different short videos around linear algebra, but the first one we're going to talk about is just what we mean by linear in the first place. So you may have in your mind an equation for a line like y equals mx plus b. That's actually not a linear function, a linear equation in the sense that we want to think about. This has an input and an output. That's going to be true of our linear equations as well. But there's also the this offset over here, which means that it's actually an affine relationship. And so what I want to show is what happens if we, for a moment, skip the offset and just think about y equals m times x. This is an example of a linear equation. And what I mean by a linear equation is it's constructed of linear operators, and a linear operator is one that the function, if you put in two arguments into the function, it's equal to the sum of the function evaluated on each of the arguments separately. And if you put in a scalar multiple, some constant multiplied times an argument, then the answer is equal to that constant times the function on the outside. So these two definitions for a function being linear are required. So if you can prove this of a function, these two steps, then you know it's actually a linear function. Let's go back here and check out what happens here. So what if I put in x1, let's start actually with the one that I said was going to be linear. This, we can say that y1 plus y2 is equal to mx1 plus x2. Is that correct? Well, yes, if what we mean is that m times x1 is y1 and m times x2 is y2. So that's fine. That's satisfying this part of the relationship. What about this one? Let's check that one out. If I multiply x times a number, y, then I get m times ax, which is equal to a times mx, which is equal to a times y. So this one is also true for y equals mx. Let's see what happens for y equals mx plus b. Let's try the first one. y1, or let's do it this way, mx1 plus x2 plus b. That equals mx1 plus b plus mx2, but that's actually only equal to y1, which is mx1 plus b, plus y2 minus b. There's a missing b for the second one. So this function is actually not a linear function. It's what is called an affine relationship between x and y rather than a linear relationship between x and y. Let's look at how that looks graphically. So we go down here to the graph where we have f of x in this direction. We have x along this axis. I have two lines drawn here. Are they both linear functions? Let's see. Well, the blue one is a linear function. The blue one, here I go over 2 increment in x, I get a 1 increment in f of x. If I do 2 plus 2 equals 4, I get 2 in the first part. I get 2 more from the second part. I add them together. So they increment in 1 and 2 plus 2 equals 4 does add up to 1 plus 1 equals 2 an f of x. And I could have just as well taken plus 2 as x1 and minus 2 as x2, and then I would have ended up at 0 for their sum, which it works. And if I multiply by a scalar, say the scalar 2, I could say 2 times 2 is 4, and 2, and so the function also is double what it would be for the first one. I could use a minus number for a. If I, instead of use x equals 2 and then minus 1, the function for positive 2 is minus 1 times the function that is at negative 2, which is minus 1. Great. What about this affine relationship? Well, yes, if we take x1 equals 2 and x2 equals 2, excuse me while I let the cat out. We take x1 equals 2 and x2 also equals 2, then this function is for 2, it's equal to 2, and for the second one, it's equal to 2. But if I take the function of x1 plus x2, that is the function of 4, it's only equal to 3. So it's not equal to 2 plus 2, which would have been 4. And similarly, if I had done it on the negative side. And also I can see that if I go over 2 versus going over 2 times 2, I would expect from this relationship that the function, whatever the value is at 2, should be double that value at 2 times 2, but instead it's just equal to 2. F of x is equal to 2 here, and then it's just equal to 3 here, not equal to 4. So the affine relationship is not the same as the linear relationship. There's one more closely related idea that's worth thinking of. So we wrote y equals mx. Sometimes we might really be interested in cases when x is equal to 0, which seems like a funny thing, m times 0. This particular combination we're going to talk about as being a homogeneous equation when we get to a little bit more complicated examples where this is not as trivial as it seems in this case. All right.